Chapter 2, number 68. For a flourish at the end of her act, a juggler tosses a single ball high in the air. She catches the ball 3.2 seconds later at the same height from which it was thrown. What was the initial upward speed of the ball? So let's draw our little picture as always. And we'll have our juggler. And then the juggler throws a ball with some unknown velocity. I'm going to stretch it out over space so we can see it, but just straight up and down. And then the ball comes to rest, and then the person catches the ball. And what we know is that this time is 0, and this time is 3.2 seconds. I'm going to solve this at least 2 different ways to show that the answer is the same, and to show that you can do it 2 different ways. So we do know that while the ball's in the air, it has an acceleration downward, which is g. What are we actually looking for? Well, we're looking for the initial upward speed of the ball, which is v0. We're looking for this guy. And we can use a couple of different ways of using the symmetry in the situation. For instance, we can use the fact that the ball comes down and passes that height at the same speed but headed downward. So it has v0 pointing downward. And then we can use the fact that at any time the speed v is the initial speed plus the acceleration in the y times the time. And if I take the first moment and then take the moment when it's at the same height, I can say that minus v0 is v0 plus minus g times the time of flight. Or minus v0 equals v0 minus gtf, and then I add gtf to both sides, and I subtract v0, or I add v0 to both sides, and I'm left with, when all that happens, over here the v0's are canceled out, I'm left with gtf, and over here I have 2v0, so v0 is 1/2 gtf. So it's 1/2 9.81 meters per second square times 3.2 seconds, which is 15.7 seconds, which I guess technically should be 16 seconds since we only had 2 sig figs. Alternatively, we can use the symmetry in a different way. We can say that the highest point occurs at a time which is 1/2 the total time of flight. In this case 1.6 seconds, and at that time the object is at rest at the highest point. It's no longer rising, hasn't yet begun to fall. So I can also go through and say that v is v0 plus ayt, or 0 is v0 plus acceleration of g downward times 1/2 the time of flight, or v0 is 1/2 gtf. And since those are all the same numbers in the same form, this must also give me 15.7 seconds. There's even a third way. We can use the fact that it starts and ends at the same place, which happens to be what we'll call 0. And we know that y equals y is 0 plus v0t plus 1/2 at squared. And if we take the ending point to be tf, then we know we ended at 0, we started at 0, we have this unknown thing times tf, and we have a known acceleration times tf squared with a half. So 0 equals v0 tf minus 1/2 gt squared, f squared. Except that was terrible, so I'm going to rewrite it. v0 tf minus 1/2 gtf squared. And then I'm going to play a little bit of a trick algebraically, and I'm going to factor out the v0, the tf. And since it appears in both this term and this term, I'm going to pull it out, and I'll have a tf out here, and I'm left with v0 there and minus 1/2 gtf. And then there's a property from algebra that if 2 numbers multiply to 0, then one of them must be 0, possibly both, but at least one. So either 0 equals tf, or 0 equals v0 minus a half g tf. And so this first one is kind of crazy. It says that he catches it at the moment, or she catches it at the moment she throws it. What it really says is that this is telling us the time when the height is 0. And there are 2 such times, at the very start or at 3.2 seconds. So this one is true, but not particularly informative. The other side, on the other hand, says that v0 equals 1/2 GTF. And again, we've reached the same numbers, so we know this is also going to be 15.7 seconds. What we see are 3 different ways to reach the same endpoint, and any one of them is fine. So whichever one occurred to you would have been okay. Hopefully all 3 of them make sense at this point.